able to figure out how to match you and return y'all, and we were able to use a regular inside the regular expression a character class that represents either lowercase y or uppercase y, and then the literal characters OU that will match that. So let's talk about how we can handle the word something like fishing. So one of the things that you may know about is that the string class has a function called ends with. So it is true that the string fishing ends with, um, let's see, so if we run this here, the string, this string does end with the letters ing. So we could actually use that to our advantage. Here we could say if the word dot ends with ing, then we could return the word up until the last character. And then we could replace that with an apostrophe. So think about that. Let's see if that works. Match is not defined. I have to say you match like that. This will work almost. It will handle the word fishing, turn that into fishin'. Aching turns into akin, but swing gets turned into swin, which is we don't drop the final G from swing. So this is doing this for every word that ends with ing, and that's not quite what we want, which is just why we write tests. This is the whole idea. So that's one way we could do it. Let's talk about how we might do it with a regular expression that does almost exactly the same thing. We can use an anchor with a regular expression. I'm going to comment this out for a little bit, and I'm going to say we're going to create this other match, which is going to be ing match. Whoops, what just happened there? Ing match. And I'm going to say RA is going to try to match the pattern ing, and I want that to be anchored to the end of the word. So I'm going to use that, the dollar sign there, to do that. And it's pretty common. I like to put those kinds of things right next to each other. So this is the U match, trying to match the word you, and this is an ing match. So if the U match is true, then I want to handle this. And then I want to handle if the ing match is true, then I could return essentially the kind of the same thing. I could do this exact same thing right here. I could return that, but it's still going to fail. But I'm just going to show you that this is another way to write that. It's still going to fail. Let's see, fishing. If there is a ing match. Let me just think about what I'm doing here. Oh, it's returning none. Because it's doing from the beginning of the word. This is going to need to be changed to a search. So let's run that. So to know, match starts matching at the beginning of the word. Here we're looking for the search to go anywhere in the word, start matching anywhere, and we're trying to match a pattern at the end. So we need to change this to be the search method, the search function instead. So we're using search here to try to match ing at the end of a string for this given string, and that shows it will match the ing. So here I'm showing you that just as we can do that, we with the ends with it finds the same thing. We can use this what we saw earlier with using capturing parentheses to capture the root of the word, the first part up to it. So what we could add here is dot here means anything. So one or more of anything followed by ing, and then we can get out that first part. So just as we saw here, this match group 1, we can, I'm going to comment this out here for a moment, and this is going to be from the ing match. It's going to get group 1, and it's going to add the apostrophe. It's going to be in apostrophe because we're we're matching here up to the ing. So that's what we're capturing, whatever occurs before the ing. So we want to take the whatever is matched here and then add the string in apostrophe. If we run that, we're still going to fail and pass the same test. Fishing and aching is fine, but swing still doesn't work. So we have to take care of this first part. We have to look for the presence of, well, we have to figure out if this is a one-syllable word, essentially. And the mnemonic I'm going to use for that, the little shortcut, is just going to be, does it have a heuristic? Sorry, not a mnemonic. And the heuristic I'm going to use is that if there is a vowel in the first part of the word, then it's probably a two-syllable word. And if there's no vowel in that first part, then it's probably a one-syllable word. So for instance, swing, the first part of that word is going to be SW. So that does not have a vowel. So we're going to say, okay, that looks like a one-vowel word. A one-syllable word. So let's get the first part. Let me see how I wrote it here so that I don't confuse things yet. I called it first. So the first part of the word is going to be equal to whatever is in group 1. Let's get rid of that for now. And we can say if it's true that we match, well, we can use search here because we don't care where it happens. If we match A, E, I, O, U in the first part of the word, then it looks like a two-syllable word, and so therefore we want to return first plus in apostrophe. Else we want to just return the word. And actually, what we want to do here is that's actually the thing that we want to do in any case. If neither of these works, we want to return the word. So if it's true that it matches the word you, regardless of case, we want to return y'all. If it's true that we have an ing match and the first part of this has a vowel, then we want to return the first part of the word plus in apostrophe. If neither of these is the case, then we want to return the word itself. And I'm going to get rid of that code right there and clean this up a little bit. And I believe this is going to pass our test now. What is it? Oh, I need to handle this being a case-insensitive match. So I want to see how I did it here. I think I would probably need to lowercase the word. That's one way to make sure. Let's just look against the lower part of the word. That's one way to handle a case-insensitive match. Another way would be to use the RE ignore case flag to say ignore, don't take into account the case when we're comparing these. And that was specifically why I wrote this version, this test with a capital letter. I wanted to make sure that I was handling case-insensitive searches. So learning how to write tests is very, very important. So, obviously I wrote this whole program, and at the end I came back and said, okay, these seem to be the main things that I need to capture. So I didn't come into this, writing this test a priori, knowing exactly what to write. I worked through the whole example, and then when I decided to teach this, I said, okay, well, I'm going to present these as the test cases that I need to test for. A lot of times as you're writing a program, you'll realize as you're going through the program that you need to add another test because you didn't think of everything the first time through, and that's completely normal. So as you discover that your algorithm or your function is a little incomplete, you fix it and you add the test to make sure that fix stays in place. So now we have a couple things here, very important. We have a way of splitting our text into things that are words and non-words, and now we have a function that will take a word and will possibly alter it according to the specs of the program, and either return that altered word or will return just the word itself. And so now we need to figure out a way to put all this together to make our program pass the test case. And that is basically, I think that you should be able to take these ideas and find a solution that will pass the integration test that I've given you. So thinking about preserving the structure of the incoming text using split lines. Here's an idea here where we have some words, and then we go through each one of these, splitting this on that regular expression that we talked about, splitting the line, and then frying that word and appending that to words, and then printing the words back out again, joined on that. And so, really, here, keep in mind that I call it word here, but it's really just a thing, right? It's either going to be, it's a sequence of characters. It might actually be a word, or it might be the non-word. And our fry function is written in such a way that it's only going to alter the things that look like you or an ing word with 2 syllables. And everything else is just going to be returned unaltered. So we should be able to do something like this. When you see this pattern of maybe starting off with some sort of an empty array, an empty list or an empty string, and then using a for loop to build it up, like with this append method, you might immediately jump and think, oh, that could be better written as a list comprehension, or maybe you might want to try to find a way to use a map statement. So that should be enough to get you going. That's a lot to absorb about regular expressions. It's a really, really deep and fascinating subject. Hopefully you have enough to write the solution, and I'll see you for that discussion.